This is an example of a simple object moving around in a circle. What we've got is we're going to draw an object traveling around in a circle. So I've got my circle here and my object here, and it's traveling around in a circle in this direction. And I want to draw vectors representing, or arrows representing, the velocity and acceleration and the force acting on the object. Well, if this is traveling in a circle, that means the velocity at any given moment is tangent to the circle. So this would be a velocity, this would be a velocity, anything tangent to the circle. Next thing we need to do is draw the acceleration. Acceleration is always towards the center for circular motion. At any given time, you know what, let me do that in a different color. At any given time, that acceleration is pointed towards the center of the circle. Net force and acceleration are always in the same direction, so the net force is also always towards the center of the circle. That net force is also referred to as the sum of the forces, and in this case, since it's traveling around in a circle, that would also be, so sum of the forces is the same as net force, net meaning we add it all up, and in this case, since this is circular motion, this would also be our centripetal force headed towards the center of the circle. Second part of this question is, if the object in number 1 has a mass of 10 kilograms and completes a circle with a radius of 4 meters 4 times every 12 seconds, we want to find the speed, acceleration, and net force on the object. In other words, the centripetal force on the object. So let's start out with the speed. We know that speed in a circle is going to be equal to 2 pi r over t. T is the number of seconds per revolution. So for this case, it completes 4 revolutions, 4 times around, 4 complete cycles every 12 seconds. So that means the period of revolution here is 3 seconds, 12 divided by 4. So that means that our circular velocity, or centripetal velocity, is going to be 2 pi times the radius, which is 4 meters, divided by that 3 seconds, which is equal to 2 times pi. I can't find it on here. Oh, there it is. Times 4 divided by 3. That's 8.34, or excuse me, 8.38 meters per second. 8.38 meters per second. The acceleration, centripetal acceleration, is equal to v squared over r. We just figured out the velocity, so we're going to take that 8.38 meters per second. We're going to square that, and we're going to divide that by the radius, which is 4 meters. And that gives us, let's see here, take that answer. We're going to square that, and then we're going to divide that by 4. So that's 17.5. 17.5. That would be meters per second squared. We can see that on top we're going to have a little sidebar as far as the units go. We've got meters squared over seconds squared on top. That's from this meters per second squared, or 8.38 meters per second, squaring that whole thing, over meters. So this goes to the bottom. These cancel, and I wind up with meters per second squared. And that would make sense since this is an acceleration. Last thing we need to find is the net force on the object, or the centripetal force. So F net, sum of the forces, is going to be that centripetal force, which is going to be equal to mass times acceleration. So that's going to be equal to the mass, which is 4 kilograms, no, 10 kilograms, times the acceleration, 17.5 meters per second squared. So that would be equal to 175 newtons. A kilogram meter per second squared is a newton. So my answers are right here, along with this diagram.